Hello. Okay, I will show you how to design a buck converter. Okay, and then simulate the buck converter. Okay, so if you have the textbook, okay, you have to look at the equation. So the important one is only three for buck converter. The first one is the output voltage. Okay, if you look here, okay, you can see here V out is equal to V input or V source multiplied by duty cycle. Okay, that is the first equation that is important to design the buck converter. The second equation that is important is the continuous current mode. Okay, for buck converter, you have to design either you can use continuous current mode or discontinuous current mode. But if you want to do a continuous current mode, you have to use this formula. Okay, and the third part is the ripple factor, the output voltage ripple factor. So this is the third equation. So this is the example if you want to understand how to calculate the formula. Okay, so let's start with the design. So I suggest you use Excel. It is a good way to see the difference. Okay, we start with, for example, for your case is you have V out, you have 2 V out. Okay, for example, you want to create a 10 volt and 20 volt. Okay, how about the P? Okay, for example, you want to make sure that the power is always the same. So for example, it's 20 and 20. Okay, so how to calculate the R out? Because if you given only the output voltage and the input voltage, output power voltage and output power, so you need to know how to get the R out. Because if you can see here, okay, you need to have a R out. Okay, buck converter cannot work without R out. Okay, so this is the R out. Okay, and to do the calculation here, when you want to calculate the inductor, you need to R out or R, or the ripple factor. Okay, for the ripple factor, it's not affected by the IR. Okay, R out, but it is affected by the L, which is affected by the R. So you need to calculate this. Okay, so how to calculate this? Of course, you just use the power law. The P equals to V squared over R. So if you manipulate that, you get V out. Okay, power of 2 divided by the power. Okay, so V squared divided by P. So you get 5 ohm, and if you want to set the 20 volt, you get 20 ohm. Okay, that is how you calculate the R out. Next in the design is you have to calculate the duty cycle. Okay, so for example, okay, V in, okay, usually V in is constant. Okay, for this case usually constant. For example, it must be higher. Okay, buck converter is step down voltage. So example is 30 volt, the input is 30 volt. Okay, so how to determine the duty cycle? Okay, so the duty cycle is basically, okay, if you look here, V out divided by V in. So V out divided by V in. So you get 0.33, maybe 40 is easier. Okay, 40. So if I drag this, I get 0.5. Okay, you have 2. Okay, because you have 2 load, okay, that wants the same power, you will get 2 resistance and 2 duty cycle because you have 2 voltage level. Now you complete the duty cycle calculation. Next, you calculate this one. Okay, so if you can see here, okay, for this one you can see you already calculate D, you already calculate R, but you don't know F. Okay, for F you just choose 1. Okay, make sure for these two, if you want to use only one buck converter, the frequency is fixed. Okay, for example, I choose 30 kilohertz. Okay, so the frequency needs to be the same. Okay, so for the same as this case, it is the same. Okay, now you calculate the minimum L. So if you can see here, you just equals to 1 minus, where is the D? Okay, this one, multiply by R out. This is the R out, divide by 2, divide by F. Okay, make sure you divide 2 times, or you can use a bracket here and then multiply. Either way, okay, make sure you recall back the Boltzmann's law. Okay, so automatically you get this. Okay, 0.00. So I suggest you use scientific. This is much more easy to look. So 6.25 E negative 5. Okay, make sure you know what is this mean. So this is the original one. So if you write it in the scientific form, you get this. Okay, so you drag this. Okay, you drag this, you get the minimum inductor. Okay, to ensure continuous current mode. Okay, so next is C. Okay, the next thing you have to design is the capacitor. So of course, the same way you look at the equation. Okay, equals to 1 minus D. Okay, sorry. So D is here. Okay, divide by, so open bracket, close bracket, inside there. Okay, inside there you put 8 multiplied by L. This is the L, and then multiply by the ripple factor. Okay, I forget the ripple factor, so for this case I just leave it 1. Okay, so for ripple factor, okay, R V out, for example. Okay, you cannot use R. Okay, how about Y V out, the ripple factor? So usually we use 1 or 2%. Okay, depending on the standard, but usually around 1%. Okay, you cannot just use 1% here. You have to use 0.01. Okay, so you don't want to use the scientific, you go to general. Okay, same as here. Okay, ripple factor should be the same. Okay, to design one buck converter. Okay, we continue back here. Okay, the ripple factor is, instead of 1, this one. Okay, and then multiply by the frequency power of 2. So automatically you get the capacitor. Okay, so you get 2 value. Okay, when it comes to boost converter or buck converter, okay, the resistor you can change. Okay, the resistor you can change, but the L and C is kept constant. Okay, you cannot change L and C. So in this design you have 2 value. Okay, you have 2 value. So the common way to do this, to find the L and C, okay, because L and C only one value only. So remember here, the L and C, where is it? Okay, okay, this is the minimum. So means that you have 2 minimum. Make sure you choose the largest. So how to do this is just equals to max. Okay, you have to choose the maximum value, highlight it, enter. So you can see here it choose the highest value. Okay, same as here, the C is equals to max. Okay, you choose this, between this, it will choose the highest value, which is this one. Okay, so this is how to design the buck converter. Okay, so the important one is, okay, the output resistance, the duty cycle, and the inductors. Okay, Okay, you complete the design. Now you will move on to the next part, which is the simulation. Okay, so open MATLAB. Okay, press the home and then simulate. Okay, and then create a blank model. Okay, so this is a model. Okay, and the component is in the library, this one. Okay, so you have a lot of library here. You have Simulink library. Okay, you have Simulink library. You have Aerospace or Simscape or something like that. Okay, okay, you will use the Simulink library, and another one is a power library. Okay, okay, this one you have to be careful because you cannot just search here. For example, you search inductor. Okay, if you search inductor, you have a lot of inductor here. You have a mutual inductor. Okay, this one variable inductor. Okay, if you can see here, this is the EE library. Okay, EE lib. Okay, this one is the from the power library. Okay, so you have multiple library and you cannot connect it directly. Okay, you cannot connect between two different library. So to avoid this confusion, I suggest you open back the MATLAB and write power lib. Okay, means that you only open power library. Okay, so this is the power library. So make sure you only use power library and as well as Simulink. Okay, how to design it? First, of course, if you check back the buck converter, okay, you need to have all of these components. So how to obtain this component? Okay, of course, the first one is the electrical source. Okay, you have to have a DC source. Okay, and then for element, okay, resistor, inductor, capacitor. Okay, so you have to use the RLC branch. Okay, so you just drag this. Okay, you choose R. Okay, choose L, and then you choose C. Okay, okay, how you know how to copy, right? Just press Ctrl and then drag it. It automatically create a second component. Okay, and how to rotate is just Ctrl R. Okay, click it. Okay, click it, Ctrl R. So you can create a resistor, capacitor, and then okay, inductor. Okay, inductor. And then how about the component, the electronic part? So you go back and then you click the power electronic. Okay. Okay. So for this case, I suggest you use the MOSFET. Okay. Use a MOSFET here and then use a diode here. Okay. Of course, click the diode one time and then Ctrl R. Okay. So check back the book. Okay. So goes here and then goes here. Then goes here. Goes here. Okay, go here. Okay, and then go here. Now you complete the buck converter. Okay. So although this is completed circuit, but you need to have other component. Okay, when it comes to this library, go back here. Okay, when it comes to use the power library, you have to put power guy. Okay, and okay, so because your design is the ideal one, you have to make sure you double click the diode and then you change the forward voltage. Okay, if not, the result will be problematic. So I suggest you put around 0.01. Okay, and then the MOSFET, you change the RDS on into 0.01 also. Okay, others just left. Okay, so next you already put the power guy here. Okay, just put anywhere. and then you have to do a measurement. Okay, you can see here you have current measurement and voltage measurement, so you need to have both. Okay, just highlight and drag. Okay, and another thing, so if you want to, okay, so go back and then go to power electronic. Okay, remember that buck converter requires pulse width generator, so go inside the power electronic and again at the down here go to pulse and signal. Okay, so if I look here, you choose the PWM generator DC. Okay, make sure you choose this one. Okay, and then you double click here. Okay, make sure the switching frequency follow your design. Okay, this one is 30. Okay, and then of course the duty cycle here. Okay, for the duty cycle you cannot. Okay, you cannot use. Oops. Okay, you cannot use power library. You have to go back to the main library here. Okay, this is the main library, and then you search for the sink or source. Okay, source, then constant. Okay, for this one is the D, duty cycle. Okay. Okay, for the first case, we use this one. Okay. Okay, we take this value. Okay, the duty cycle, where is it? Okay, 0.25. 0.25. Okay. So next, you have to set this. Of course, the input voltage is 40. Okay, inductor, remember you have to choose the highest one. Okay, you have to choose the larger one. So just copy it, 1.6 7E negative 4. Okay, same is here, capacitor, just copy it, 1.67E negative 4. Okay, so both are same value. Okay, for this is just a coincidence, but if you use a different design, the value will be different. Okay, so you already choose the inductor, the capacitor. How about the resistor? So you choose the first case. Okay, remember for 0.25 you have to use 5 ohm. Okay, 5 ohm. Okay, so for this example, your objective is the to maintain CCM, continuous current mode, for both load. Okay, okay, second one is maintain ripple factor, output voltage ripple factor less than 1% for both load. Okay, the third, okay, of course, we mentioned both load. So what is both load is, okay, both load maintain 20 watt of power. Okay, maintain 20 watt of power. Okay, remember here, your output power maintain 20 watt. And then your another objective is, okay, one load, okay, is receive 10 watt, 10 volt, and another load 20 volt. Okay, then separately. Okay, you have to make sure that the load is separately. You cannot just combine the load together. So if you want to change only the load and the duty cycle. Okay, this is your objective now. So how to achieve this? Of course, you for the second objective, you can see here you have 10 volt and 20 volt. So you have to measure the output voltage. So how to measure it? This one. This is the output voltage. Okay, maybe I just single click this and change it V out. Okay, and of course you have both load maintain 20 watt. So when it comes to watt, you have to measure voltage and current. So let me delete this, click one time, delete it, and combine it back. Okay, and combine it here. Okay, now this is okay. Let me save this first. Okay, so make sure you save, because sometimes they can gone. Okay, and then this one is basically I out. Okay, now the V out is the average voltage. Okay, so when it comes to average, you go here, you go to the measurement, the power library, go to the measurement, additional measurement, and you look for the, okay, let me make it larger. Okay, you look for the top one, which is mean. Okay, so if I bring back here, okay, this is the mean. Okay, make sure the frequency you set it 30 hertz, 30 kilohertz. Okay, so you need to measure the mean. Okay, and then how to display this? Okay, you have to use, okay, go back to the main library. Okay, this is the main library. Go to the sync and then show the display. So this one is average V out. Okay, mean means average. Okay, now you already get this. Okay, so you already achieved the first objective, the second objective. Now look back for the second objective, the power. So you go to the math operation. Okay, you go to the dot product. Oh, the product here. Okay, don't use the dot product, use this product. Okay, of course, to calculate the power, you have to, okay, multiply V out, I out. Okay, P equals to V I. Okay, and then this one is the P out, instantaneous P out. It's okay. If you want to make the average P out, okay, you just copy this and then place this. Okay, you get the average P out. Okay, so you already obtained the first and second objective. Now the third objective, continuous current mode. Basically, to measure the continuous current mode, you have to look at the inductor. So this is the inductor. You have to put a current measurement here in series. So if I take this, okay. Okay, so this is basically IL, inductor current. So you have to make sure that it's never go to zero. So here you cannot use display because you want to see the, okay, waveform. So you go to the sync, okay, the main library, go to the sync and goes to the scope. Okay, measure here. Okay, the IL. Okay, now another thing is you have, this one is the objective 3. Okay, how about objective 4? Okay, objective 4 is the ripple factor. So ripple factor, okay, so Y V out, output voltage ripple factor, equals to V out, okay, max, okay, maximum output voltage ripple factor minus V out minimum voltage ripple factor, and divide by V out average. Okay, so let me underscore this. Okay, okay, so the average V out is this one. Okay, V out underscore AVE. Okay, So this is the formula. Okay, so maximum and minimum you have to use the scope. So double click the scope. Okay, go to setting, make sure you have two input. Okay, this one is different based on your MATLAB. So other MATLAB version, it will produce different setting. Okay, so basically the first one, okay, you go here, okay, and then you go here. Okay, so basically V out D minus V in. Okay, so this one you take from the, okay, sorry, this one should not be here. It should be the original voltage because you want to look at the minimum and maximum. Okay, you have to look at the output voltage, instantaneous output voltage. Okay, so now you already achieve objective number 4, which is the output voltage ripple factor. And of course, this one is background is not very good, so you have to right click at the empty space here, go to style, and then change to white. Okay, because you want to write a report, make sure change it to white, and then the color of the line should be changed to the darker one. Okay, and then how about the second? Okay, this one, the second channel, what, blue? Okay, apply. Okay, okay, still not changing. Okay, oh, okay, I forget to save it. Okay, second channel is blue. Okay, okay, you already design the simulation. Okay, transfer the simulation design into this MATLAB. Okay, so simulation time I suggest is around 0.01 maybe, or maybe 50 millisecond, 50e negative 3. Okay, 50 millisecond. And don't forget, okay, go to the modeling, okay, and then go to the gear. Okay, click the gear. Okay, make sure you are in the solver tab, choose variable. Okay, solver detail, maximum step size you have to change it to 1e negative 6. Okay, there is a reason for this, but I will not show it. So make sure you change this to 1e negative 6, 1 microsecond. Click OK. Okay, and then you can go back to the simulation. Okay, don't forget to save and run the simulation. Okay, so you will get this result. Okay, because you are focusing on the steady state analysis, you just go here. Okay, logging, you just limit it maybe around, I think 500 is enough. Okay, limit the data point. So let's try again. Okay, and then you click here. Okay, maybe reduce it back. Okay, click here, maybe, okay, depend on you. Okay, just I think 300 is enough. Okay, run it again. Okay, don't forget this. Okay, click here, make sure you put here. Okay, automatically it will zoom in the result. Okay, when you want to take the result, make sure then you don't take it very large. Okay, if you take it very large, it's quite hard to insert it into the report. Just take it small. Okay, the top side is the inductor current. Okay, and the bottom one is the output voltage. Okay, so to measure this, go to the ruler. Okay, okay, because you want to measure the, okay, the first one, if you look here, to ensure the continuous current mode, you have to take picture here, the minimum current. Okay, you can see here the minimum current. Okay, so maybe I change the style. this one change to black. Okay, now it's much more clear. Okay, you look here, the minimum current. Okay, look at the first one because this is the first one. Okay, this is the first one. Okay, 1.28. So means that it is more than 0. Okay, and more than 0 means that it is a continuous current mode. Okay, now move to the second part with the V out. Okay, you move it to the maximum value. Okay, and then this one to the minimum value. Okay, automatically you can see here the Y part. Okay, this is the maximum minus minimum. So 3.716 E negative 2. Okay, so remember this formula. Okay, so 3 point, where is it? Okay, this is 3716 E2. 3.716 E negative 2. Okay, divide by V out average. Okay, this is the V out average. Okay, 9.986. So you will get the ripple factor. So as long as the ripple factor is less than 0.01, you achieve objective number 4. Okay, the previous one, okay, remember here the upper side is the objective number 3 to maintain continuous current mode. Okay, how about objective number 1? Okay, 20 watt. Okay, almost close to the 20 watt. Okay, your objective is achieved. You cannot get the full correctly. Okay, you cannot get the 20 because you have non-ideality here. Okay, there are non-ideal component. And then the output voltage 1 is 10 volt. Okay, this you get 10 volt. So all of the objective is achieved. Okay, almost all, because you remember here you have to make sure both load. So now you record everything. You make sure you take the picture for this one and this one. Okay, show the value. This is the important one, and make sure you change the style to black. This one change to black because it is much more clear. Okay, and make sure don't make it maximize. It's hard to insert to the report. Okay, now you already obtained the first load. Now you have to change to the second load. So for the second load, of course, the capacitor and inductor, you cannot change it. You have to make sure you choose the highest one. But the duty cycle and the output resistance change to this 0.5 duty cycle. Okay, 0.5. And the resistance, you can see here, where is it? The resistance is 20. So change the resistance to 20. And then you run it again. Okay. Okay, make sure you save before you run. Sometimes it can hang. Okay, you can see here, first objective is 20 watt. It's achieved 20 watt. Okay. How about the voltage? You set it 20 volt. Okay, you achieve 20 volt here. So correct. And how about the continuous current mode? So press this. Okay, this is, it will automatically ensure that your graph is within the limit. So you have to look at the IL first. Okay, make sure you look at the lowest point. Okay, move it to the lowest point. Okay, you can see here is the first one point is 3 point something. Okay, 3.16 negative 2 means that it never goes to 0. Okay, means that this is a continuous current mode, very close to 0. Now you of course go to the V out, look at the maximum output voltage, then minimum output voltage. Okay, so you can see here the difference between minimum and maximum, 4.959 E negative 2. Okay, don't forget E. Okay, that is very different. Okay, so make sure you insert into here. Okay, the value here, where is it? 4.959. Okay, 4.959. Okay, and the output voltage, of course, you take here 20.06. Okay, so don't forget, if you want to get it in the percentage, multiply by 100. Okay, that is how you calculate the ripple factor of the output voltage. So you get this one. So basically you already achieve both four objectives for both load. Okay, that is how you conduct the experiment. Okay, if you want to maximize this, just press other empty space and then spacebar. Okay, you can take this picture, so easier for you. Okay, that's it. Okay, good luck with your lab.